In this video, I will explain the differences between in-context learning, fine-tuning, and continual pre-training. First, ICL stands for in-context learning. It involves adding examples to a prompt to guide the model in understanding the task. Using examples to activate the model's capabilities is referred to as ICL. Next, fine-tuning involves updating the model using a small dataset to enable it to perform well in a specific area. Fine-tuning fundamentally modifies the model. Finally, CPT stands for Continual Pretraining. CPT is part of the pre-training phase and aims to provide the model with broader general capabilities. For example, a model may support English but not German. Through incremental pre-training, we can improve its German proficiency. Similarly, if a model lacks understanding in the medical domain, we can use a large amount of medical data to provide it with general medical knowledge. Now, let's analyze these methods across several dimensions. First, parameter updates. ICL does not update model parameters. It simply adds examples to the prompt during inference. Fine-tuning updates parameters using a small dataset to enhance the model's capabilities in a specific area. CPT updates parameters to broaden the model's general knowledge. Second, data requirements. ICL does not require training data, as it does not involve training. Fine-tuning requires a small amount of data, ranging from thousands to tens of thousands of examples. CPT requires vast amounts of data, typically tens of billions to hundreds of billions of tokens. Without sufficient data, CPT is not recommended, as its impact on the model will be minimal. Third, efficiency. Here we mean training efficiency. ICL does not involve training, so training efficiency is not applicable. Fine-tuning. Training efficiency depends on the model size. For smaller models, for example, models with 1B, 2B parameters, fine-tuning is relatively efficient. For larger models, efficiency decreases. CPT. Extremely low efficiency due to the need for large-scale training. Fourth, flexibility. ICL. Highly flexible. By simply providing examples, the model can respond effectively. Fine-tuning. Relatively less flexible, as it involves training the model. CPT. Very low flexibility. Fifth, cost. ICL. Low cost, as it does not involve training. The main cost is the increased prompt length due to added examples, which slightly raises inference costs. Fine-tuning. Relatively high cost due to training requirements. CPT. Extremely high cost due to the large-scale data and resources required. The last one, practicality. ICL. Highly practical. In most cases, we should try ICL first. If prompt engineering alone is insufficient, adding examples to the prompt is a simple and effective solution. Fine-tuning. Less practical. It is recommended only when the general-purpose model cannot meet the task requirements. Fine-tuning often requires multiple iterations to achieve desired results, making it resource-intensive. CPT. Rarely practical. It is relevant only in specific scenarios, such as when an organization aims to lead an industry by developing a domain-specific large model for its ecosystem. In general, CPT is unnecessary in 99% of cases. These are the key differences between in-context learning, fine-tuning, and continual pre-training. For more detailed explanations of each method, check out my previous videos on the subject.